Good day, everybody, and in this video, we're going to talk about control structures in programming languages, and to be more specific, in the Visual Basic 2017 platform. Uh, from the word control structure, we learned that the program can be made to make decisions, and the flow of program execution can be controlled so that it can either one move from one part to another, to execute number of times, or perform something based on some conditions or some rules. So that is what a control structure is. When we see this in our notes, this is what we get. We get that we can learn to write a code that makes decisions. So decisions can be made. That's the very first thing we need to note. So and control the program flow in the process. So decisions can be made. So a program can be we can have a program that can make decisions, and also that can also control the flow of execution or the flow of process. That's very important. So that is what a control structure is. And in programming, we have a couple of control structures. So that is what we are going to see. So what we need to note is this, that the decision-making process is an important part of programming, because we can solve so many problems in a smart way. So that's why we need a control structure. It's very important. And uh, for us to use or to write a control structure, to have a control structure in place, we must use what we call as conditional operators and logical operators. That is very important. So what is a conditional operator? These are the conditional operators. These are operators that allow a program to compare values. So we need to start comparing. Let's say this is equal to this, or this one is greater than this, or less than this, or more than and equal to, etc. Once we are able to compare two values, then we can make a decision. We can say if the number of times somebody has entered a password is greater than 5, lock the system. So we are using a conditional operator to do what? To really like compare values. Either the moment you enter the password once, second time, there's a counter that keeps on counting the number of times. So we need to be able to decide what action needs to be taken up, more especially when we compare two values, and we're going to use conditional operators. Now we have them there. Another thing which is very important are the logical operators. Now, for example, one condition might not really completely cover the condition that you really want to pass across. You might want, for example, to display those who got between 50 and 60, and between 80 and 90. So when you have two or more rules or conditions that you want to bring together to make a more elaborate condition, we can use logical operators. That is an example I'm giving. So we might need to make more than one comparison before a decision can be made and action taken. And in this case, using numerical comparison operators alone is not sufficient. We need to use the logical operators. And that's why we have, for example, this operator AND. The AND, of course, the description here is that both sides must be true. For example, if you are above 18 and you are a Kenyan, For example, if age is greater than 18 and country is equal to Kenya, so both side must be true. So then either you're allowed to vote, something close to that. So that is the and then this other logical operator is or one side or other must be true. So one of the conditions must be true. And then we have the XOR and the NOT, and they're also equally important. So what you need to note here is that the logical operators can be used to compare numerical data as well as non-numerical data. That is very, very important. So we can have numerical and non-numerical data, more especially compared using these logical operators. That's very important. Now, straightforward, we will go to the easiest or the most common control structure, which is using the if then else or the if control structure. Now, if I go here, in most programming language, they call it the simple if statement. This statement works like this. The control of the program will be flowing and it will come to a point where it has to make a decision. It has to test something. If it is true, then some statements are executed. If it's false, then it means nothing will happen. So that's the uh, if if then statement. Let me see if we can elaborate it here. This is a quick example, the if flow charts. This not necessarily for visual basic, but then control structures are more or less the same, or even their representation. So let's say, for example, we're having something, flow program is coming here, and we have a test here or a condition. So if the condition is true, then statements will be executed. But if it's false, then nothing will happen, or the computer program will jump to other independent statements, or even it will come to an end of stop. Something also that those are just what examples. So that is how if flowchart works, or how we can control this uh, this program. For example, we can say if the password is correct, then perform some actions here, else nothing will happen. That's just a simple example. So let's go back here. That's the if statement. So if condition then, and then we have the expression, then we end if. So each time we use this control structure, if, we must end it right here. So we have examples there. So that is the simple if. The next important one is what we call as if then else. So we have an else part. If you come to this flowchart here, we can see that we have to test something. If it is true, some statements are performed or are executed. If it's false, also some other statements are performed. A rather simple example is this password. When you are going to enter password, if it is correct, you're going to either be allowed to access a system. If it is wrong, you're going to be blocked. So for both cases, whether the condition is true or false, some statements must be performed. This is very important. So this is how it works. It works that tests the expression. If it's true, perform statement. If it's false, perform some other statements. So that is very, very, very important. So another control structure is right here. if then else if. We can sometimes decide like to keep on nesting or having more and more if else's coming after condition. So we test one, we go to another, we go to another, so that we can at least be able to do what, to basically solve either our problem. So that can also be used if there are more than two alternative choices. Using the if and else statement will not be enough. In order to provide more choices, we can use the if then else if. So it's like we use the if else and then we use again if statement and then else and then keep on going down. So if you see that this formula here or syntax, we're just saying if condition then we have expression here if and then else if condition one then we have and then else if condition two then we keep on going down like this. We can have so many else ifs so that we can cover all the conditions that we want to test. So that is very possible and you can see it here. For example, we are trying to generate a grade for the marks that we have, either between 10 and 20, 20 and 30, 30 and 40, or 90 and 100, depending on whatever range you want. So for example, here we have dim, we're declaring integers here, and then we can come right here. We can assign the values that are being passed into these variables, and then we can ask this question: if the value that is in this variable is greater or equal to 80, then grade is A. So somebody's got an A. Else, if the grade is greater or equal to 60 and mark is less than 80, then grade is B. So we are using the else if we're using this other operator here that we just talked about. So this is how we can, and then we keep on going down until we're satisfied that we've captured all the conditions necessary. So that is very, very important. Now, select case, it's very important. Now, at times we might have so many cases. So it's like now we are going to program our program to select a case. So we can have so many cases, and maybe we just want one of the cases just to be selected. So the computer has to go and go through the conditions to see which condition meets the requirements, and that is what will be executed. If we use, if we see we see yeah this flowchart here, it's like this. Like for example, a program will start here. Let me just make it slightly smaller so that you can have the whole thing here. Okay, yeah, I think this is fine enough. If the program starts here, we come to a conditional expression that we call it a switch case that will help us now identify what is happening. For example, we can have some expression here and we'll test it using each of these cases. If this case here is true, then right here statements will be executed and will break. Break means will now go to some exit or something else out of this switch case. If this case is false, then control comes to the next and finds out if that condition is true. If it's true, this will execute. If it's false, it goes on to the next case. So the cases will keep on going down until, if, for example, the right case is met, then program is executed. Or rather, if all these cases are not met or are not coming to true, something like that, we have a default case that always executes. For example, I'll give this example. If, for example, the marks are not entered for a student, so there's no grading system, then when the program will be executing, then it can just write somewhere that no marks were entered. So if it's 20, that's a fail. If it's 80, that's an A. If it's 60, that's a B. So if it's zero or something out of the expression now, let's say if it's minus one or something like that, maybe no value accepted. That is a default case that will be executed if all other conditions are not met. So that's quite important for us to note. Let's see what we have here. So we say that select case is slightly different from if-else control. The difference is that the select case control structure only makes decisions on one expression or dimension, while else if statement structure may evaluate only one expression. So select case is prepared when there are existing multiple conditions. That's very true, very important. So for example, this is what we're talking about. Based on your grade, we can have this come there. And then let's see, if you didn't get any marks between that, you can have either a case which is called as else or default, which is either a fail if you didn't get anything above what is required. So that is the select case, which is very important. These programs are manageable, and I know we can always write them and do them. So this is an example of how that is done. We can just have a button there, and then we can have one variable which is called as mark, and the data type is symbol. So any value through these text boxes is assigned to the mark. So select case mark. So it's saying that the first case is 0 to 49, labeled if 50 to 59D, blah 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 blah, all the way. And then case else, if you enter something that is not within this cases, we have the error. So that's something for the default error. Please re-enter the mark also. So that is very important. Now, one thing that we cannot do without in programming is a loop. A loop is like something that keeps on iterating itself, performing a job a number of times. So we can have a loop. For example, when we're entering passwords in your phones, there is a loop maybe that keeps on allowing you to enter a number of times before something exists. So that's quite important. So we often need to write code that does a job repeatedly until a specific condition is met. And this process is called looping. So looping is very important. And there are three types of loops: the for, next loop, do loop, and while end loop. These are very important. Let me see if we have a diagram for. Okay, we have a while loop here, a do while loop here, then we have a for loop here. So for example, this for loop, we need to have something like a counter or to initialize something. So the control variable expression, we can have an expression, and then we continue with some decisions here. If it's true, then some statement will be performed, and then we'll adjust that expression, or the counter will count something close to that. So we keep on adding or counting or adjusting the expression each time a statement is executed until something happens. You enter a password wrongly 10 times, phone is locked. So the condition is that keep on doing something until something is met. So if the condition is false, then we have to exit that loop and go to other next statement. That is a for loop. Do while, let me see here. So do while will do something. It will first perform statements at least once before even checking for the condition, and then to check the condition. If it's true, it will again cover the statement and keep on working. If it's false, it will exit. And while loop uh, also does this, it checks a condition while it's true. As long as it's true, it will keep on executing. But when the condition is false, it will of course come out. So that is what is happening. So those are control structures. So if we use these control structures, our programs are going to be repetitive, and they're going to do very flexible things that we want happening. So that is all about control structures. And kindly please go through these programs, and it can be easy for us now to understand other complex programs that are going to be shown to us in other, uh, let me say, tutorials or other video lectures. For example, if you want to write a program of a calculator, you might be required to use a control structure. And I think it's time for us to try some of the other complex programs. Otherwise, thank you.